Hello everybody. Today let us look into combinatorics and binomial expansion. These are some of my favorite topics to discuss and to learn. So, first of all, let's begin with permutations. What are permutations and versus combinations? Permutations, and this is in general combinatorics, so we'll put this word combinations also, but what is this? How do you order things? How do you select how many things there are? How many patterns? How many possibilities? Right. So let me ask you a question as follows. Let's say there are, let's say we have a four-letter word, right? Four-letter word. And if you're doing a four-letter word, okay, yeah, four letters. Let's kind of just say that. And let's say you're selecting from, the 26 letters in the English alphabet. Well, how many possibly can you get? What are the arrangements? What are the possible, how many numbers, what's a possible number of words that you can even attain? Using a letter, for the first letter, you can get 26 possible letters for the first one. And then what happens? You multiply by another possibly 26 letters, right? And then maybe another, you could have A and A, B, and then maybe A, B, another A, or A, B, Z, A, B, C, right? A, B, F, right? So there's another 26 and another similarly 26. But again, this is something that seems to be confusing to many students when you're taught, oh, this is just the number of four-letter words, let's say, if everything was a word, considered. Four-letter arrangements where letters are allowed to be repeated, as you can see, right? 26, 26, 26, 26. But look, the confusing element of this is like, why do you just multiply 26 to the fourth power, basically, right? And the idea being, okay, is here's what's going on. If you have A, and then, let's say you have A, imagine, and then, maybe have A, and then all the way you can have A, and then, maybe A, B, A, C, and all the way to Z, right? That's 26. Now let's go to A, and then maybe we change the third letter A to a B, right? And then we again have 26 for that possibility. A, B, and then A, B, and then B, A, B, and then da-da-da, Z, right? Okay, that's already 26 plus 26. And then what if I had changing A, I keep the A, the first letters, but look, A, B, and then maybe da-da-da-da, I'm going to Z. I'm doing 26 times this 26, if you can see what I'm doing here. And so already that's 26 times 26, okay? So this is 26. And then if you do this and the kind of this combination here with this going through C to Z, the second letter, that's another times 26, right? And then what happens, what if I did the AA, made an AB, right? And so forth, so on and so forth to AZ, the second letter changing to AZ. Then what would happen is you have, again, all this with 26 times 26, 26 times 26, and you have that 26 times, where ultimately you would get another times, let's go down here a little bit, another times 26, right? And already we have 26 times 26 times 26, and imagine now you're changing the letter A, the first letter, to B, and then you have again 26, 26, 26, and you change it to a C, and you have 26 cubed again, and then you do 26 of 26 cubed, and of means basically the word problem language of multiply, right? And so we have 26 to the fourth power, right? This is interesting that this is the number of possible, let's see, I'll tell you, we're going to write it out a little bit too. 26 to the fourth power is number of possible, okay, four-letter combinations, right? And you can have anything repeating, okay? Combinations with repeats allowed. Okay, so let me actually kind of maybe move this a little bit so we can make it look nicer a little bit, right? So let's do smaller. Let's kind of put this box thing here back here, okay? And I'm going to say combinations with what is it? And order matters here, right? Like if you have A, B, B, A, that's different than B, A, B. Very different, right? So with order, that matters, and repetition allowed, and repetition. let's call it, with order and repetition. This is even before permutations and combinations. This is, you know, how many digits there are, right? How many numbers with 5 digits there are, and basically, if you don't have the 0 for the first one, it would be 4, and then, oh, sorry, 9, right? Because 1 through 9, and then you have digits 0 through 9, so that's 10. 9 times 10 times 10 times 10 times 10. That's how many 5-digit numbers there are, right? Just in a kind of verbal expression there. Repetition allowed, right? Okay, now permutations is very similar. Okay, this is basically, let's call this arrangements. Okay. Okay, combinatorics arrangements. Okay, and then permutations. What would happen is, let's go to permutations now. Okay, so permutations bring it down a little bit, and combinations will bring that even further down later. Okay, but what permutations is about is basically the same thing, right? 26 letters, but do not repeat them. Okay, so order is okay. Like, so let's basically say now number, what did I call it? Number of possible. So number of, let's say it, 4 letter. I'll just print it out. Letter words with order matters, right? With order, but no repetition. You cannot use A and then A again, okay? So if you use the letter B, then you cannot use it again. If you use AC, then the other ones cannot be A nor C, with no repetition. And this is basically, look, what would happen is you would have, let's see how we did it, what color we did it there. Okay, so you would have, yes, you can do, for the first letter, 26. That's fine, right? And then what happens is, okay, then we're left with only 25 possibilities, right? And so we're done, you know, down to just 25 allowed. And then times 24, that's the third letter, it would be only 24 possibilities, and times a 23, okay? And so this is basically, if on the side, let's talk about something here, okay? What is it, what is this, there's a symbol called, like an exclamation mark, it's called factorial, okay? So 26 factorial, okay, little circle, like, what is that, exclamation mark, that means 26 times 24, 25, I mean, goes down by 1, times 24, times 23, times 22, and you multiply all the way to 3 times 2 times 1, okay? That's what it means to do factorial. And then if you, how do we get rid of this right here? Because we don't have that right in our top. What we do is we say, you know, we're gonna divide by 26 minus 4, okay? Because we're doing 4-letter words, basically the 22 factorial, because we wanted 4 numbers left. And so that's going to be 22 factorial, which is 22 times 21 times times 2 times 1. This cancels, right? And so we have basically left, we're left that this is called, the permutations is basically how you write it is. If you choose n objects, we had 26, and we're going to permute basically 4-letter words from the 26 possible letters you allowed. And you have 4 letters, you're permuting 4. You're going to have, that's meaning this right here, okay, right here. And so what we usually typically describe it as is n permute m, and you get n factorial over n minus m. Oops, n minus m factorial. Cool, right? And that's a formula for permutations. And you can, of course, see it more visibly on smaller number of objects. For example, let's say we have, this is a very big thing to really visualize this, to really conceptualize this, because then later when problems get tough, you can actually understand what's going on. Watch this. Let's imagine we have a kind of another example here. Let's do kind of a purple color. So watch. Let's say I have letters A, B, C, and D, okay? And I'm going to do maybe 3-letter words aloud, okay? Let's even do E. No, let's do, that's enough, right? That's going to be enough, okay? So let's do 3-letter combinations. So let's do 2-letter combinations from A, B, C, D, E. Okay. So basically, I'm saying, so we're gonna have from this is a set. How many? Let's say 2-letter words. Another example. Okay. Small, similar, an easier one, right? That we could just kind of follow more easily, but you can kind of conceptualize better probably. How many 2-letter words with order no repetition. That's kind of how we're going to say it, repetition allowed. So we're going to have A and then no more A, right? Repetition. And so I'm saying this is going to be, right, 5 permute 2 equals 5 factorial over what's 5 minus 2? 3 factorial. 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. And that's just 5 times 4, right? 5 times 4 equals 20. Now look, let's actually see if that is the case, right? Like, is it really the case or not? So let's see. Let's do that because, it's something important. It's not something we just want to guess or just, think it's a formula. So look, if you do A, choose A for the first one. Then you have, B, or maybe AC, or maybe AD, or maybe AE to take care of, right? So that's kind of 4 there. Now take a 5, no, take a B now for the first one. Then you have 4 left, A, no B, but C, D, and E, right? And then you also have, of course, you can have the first one being, what if it was a C, right? And so we can do the same thing with C. Let's just keep on going. Oops, let's just keep on going down. Let me actually kind of do this, so we can kind of diagonally do this. And then we have this. That was actually E, right? DE. And then B, A, C, D, E. And then C, what is that? A. So we have kind of the first letter of this one. Just kind of make sure you can visualize it on one page. Otherwise, I put it all down. First letter circled, A, and then B, C, D, E. B and then A, C, D, E. What is that? C and then A, B, D, E. Let's even write them all out. And then, so what? We can do that. And then D, what if it was D the first letter? Then I have A, B, C, and E. And finally, we could do E, right? The fifth letter. And then we have, of course, 4 for each one of those letters. The first letter is being chosen already. A, B, C, D. Cool, right? And so that is exactly, look, 1 second, let me show you how you would count it. 1, A, B, A, C, A, D, A, E, right? Let's see if I can write it there. It was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. You see that? That's cool, right? And so there are indeed 25 times 4 combinations, but now you probably saw why it's 5 times 4. Okay, now, what is combinations versus, this is when, like permutations, okay? It's like permutations, but now when we choose, let's say, K objects, okay, from, this is kind of basically choosing, that's what C is about, from, right, like for example, we had 26 letters from N, and order does not matter. And notice that, of course, if you're choosing, like, let's say 3 things, so like 3 students from, they're going to be already different. So you're not going to repetition. So, and also, and no repetition, no repetition. So that's, if you're choosing, obviously you're not going to choose like 3 students, they're all different students. So no repetition is understood usually, but again, let me say no repetition allowed as well. Okay, so no repetition allowed as also. Okay, so this is what choosing, it's like permutations, but so no repetition permutations neither, but you have an order does not matter. Okay, that's a big thing. So now what is happening, this is a little trickier. Let's do the kind of the purple example there. Let's choose 2 from how many, two group. So let's do this. Let's have students A, B, C, D, maybe the first names like Andy, Bob, Catherine, David, and Elaine, right, for example, or something, E. And then we have choose 2 from the 5 students, let's say, right? This is called like different people now. Obviously, you're not going to repeat the same person. There's only one of each, right? And so basically, you write it as like a 5, or you can do 5 choose 2. So, or 2 choose 5. Usually, depending on how the convention is, you can sometimes put the bigger number on the left, and then that's what you're choosing from. But 2 choose from 5, 5 choose 2. You can also sometimes you can see this, by the way. Okay, I'm going to erase that, but sometimes you see that instead. Also, this is equal to 5 choose 2 this way. That's also called 5 choose 2 right there. All right, and what this means is, let me just show you, it means 5 factorial over, it's going to be, like we did, 5 minus 2 factorial, that was before, right? And also we're going to divide by the 2 factorial. And I'll show you why. In fact, the formula is, I'll show you why. This is not just, something we're going to make up. And so, but if you do n, choose m, which is n, m, n choose m like that, that's going to be n factorial over n minus m factorial, m factorial. This is a formula, and it's always going to work. It's really cool. But now let me show you what I mean by why is this going to equal to, let's see, let's get the purple one ready. Where's that? Why is this actually equal to what it is? So 5 factorial, 5 times 4 times 3 times 2 times 1. We're trying to, how many basically groups of 2, how many pairs of students are we going to have if we, possible pairs of students are there? Maybe Albert, whatever, A and C, maybe B and E, maybe B and C, maybe C and A, but no, C and A is A and C, so you don't want to repeat that, right? So anyway, look at this. We're first going to count them just to see what we're expecting. 5 times minus 2 factorial is 3. So 3 factorial, 3 times 2 times 1, times the 2 times 1, right? We have this, this, and this. And guess what happens? This cancels with that, and then what's 5 times 4 over 2 times 1? It's a 20 over 2 is a 10. So that should be the answer. Now look, let's actually figure this out. We had, remember, we did have A, B, A, C, A, D, A, E, right? But we also think about it. And then we have, BA, B, let's just kind of pretend like we don't know what we're doing. We're just going to just write a B. So we're going to write the 20 like we used to, the permutations, and then we're going to see why we have to cancel half of them, basically. Why we divide by the 2, right? Well, we cancel 10 of them, really. So BD, BE, right? And then we, of course, have CA, CB, CD, CE. I'm just basically copying what we had above. And then DA, DB, DC, DE, right? And then finally, EA, B, EB, EC, ED, right? Okay. Now, you see this A, B, and BA? Don't worry about that one again. AC and CA, don't worry about that one again. AD, well, D8. So we don't do these again. We already have the A for all of those. Now, so you see, what happens is we use A for the first one. We don't ever use A again for the second one, right? Because we already had it for the first one. Okay. That's really tricky. Then, like BC, well, we already had. Here's BC, here's a new one, right? But we don't want to do anywhere where B is the second. So this, we don't want to repeat. Okay, BD, okay, that's different, right? What's BD? Well, we already did BD and BE, okay. What about C, CD? If C is first and you get CD or CE, then you cannot have it second. So this and this go away. And finally DE, this goes away. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ta-da. And then basically half of them went away. You can see there's some patterns to it, whether it's a kind of a geometrical, like a matrix kind of where you have a diagonal, like the top right goes away, the bottom left remains, like half of it, half of the entries. Really cool stuff. But that's one way to visualize it. Basically there it is. And then here is the reasoning. Ready? Reasoning. Okay. Here it goes. Let me kind of even write it out. It's really hard to follow. So verbally is easier. But look, you have why 5 factorial? 5 factorial because it's basically like we had where you're just having, because like you choose 5 and then you have 4 left, right? Because you cannot repeat, because cannot, right, repeat. So it goes down 5, 4, 3, 2, 1, but basically you're just choosing and choosing and choosing. Now, dividing by, we did 5 minus 2, that's 5 by 3. Basically saying, hey, look, let's just do, because we only want 2, right? To choose 2, not all 5, right? To choose 2. So we wanted basically 5 factorial over 5 minus 2 factorial, so you'll have 5 times 4, and you stop there. 2 numbers, 5 times 4 multiplied, right? Want to choose 2 only, okay? So we're not going to divide by that kind of 3 factorial, so we're left with, the 2 entries only, 5 times 4. And then what are we dividing by 2 factorial for? 2 factorial is how many combinations there are of, what is it, of the 2 that we're choosing. And of course, remember, they're different, right? But actually they're the same. So our combinations that are actually the same, that are actually, and you see that's why this is all going to work out as it does, actually the same. And that's why we have the permutations, but by an additional, you see actually what the formula will be is, if you do C, N, and M, C like that, right, what happens is to the same thing, P, N, M, but what? Also by factorial, cool, right? Okay, so that's another, formula you can do. That's true, right? Okay, anyway, let's now go to what I said, what we talked about, the binomial expansion. Okay, and actually, let me do this. Let me continue with that topic next time. Okay, so for us, we will leave it as combinatorics and binomial expansion, but really this is just a combinatorics and practice with that. So kind of a hint, I think this is just a good way to stop here and then have the next video doing that. But look, let's just kind of tricky example. One more example. So let's just do this example. So let's say I have poker cards, right? Okay. So example, how many? How can we find this? Like how many? And this is tricky. I'm going to get a tough example. Okay. How many? So you get 5-card combination. How many 5 5-card poker hands, okay, are, let's just say, full houses. How many possible full houses, basically? A full house is when you have a triple. Okay? X, like a 3, 3, and then maybe as a Y, Y. In other words, they have to be like 3, 3, 3, 10, 10, or a 10, 10, 10, Jack, Jack. Okay. Now, there are, just so you know, okay, there are 52 cards total. Okay, and this is basically because there are 13 face values. Okay, and then these are what? 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, Ace. Okay, if you don't know, and then 4, what is it? Suits, and this is what? This is diamonds. Let's just, maybe spades. And then how do I draw the spades? Let's draw the spades the best we can. And then we have, this is spades, okay? And then we have hearts. Let's see. Try to do my best here with that. Hearts. Here. So we have hearts, okay? I'm gonna write it, okay? It's kind of delay, okay? Heart. Okay, and we have, let's do diamonds. Okay, just diamond. Delay. And then let's do clubs. Clubs is like, I think something like that. Like that. So kind of like that, clubs. So, okay. So that's where the 52 come out, because there's 2 of each of those, 3 of each of those, and 13 of each of those. 13 times 4 is 52. You see already we're doing a little bit of combinatorics. Anyway, how many 5-card poker hands are full houses? Well, an example card will be, let's say, let's do this. Let's do like a 5 hearts, 5, let's do diamonds. They're easier to draw for me. And then 5, so you have 5, 5, 5, maybe spades. Okay. And then maybe a 10, or let's do like a jack, hearts. Let's do a jack, hearts. And a jack something else, let's say jack. This is a tricky problem, you'll see. Jack, maybe diamonds, whatever, right? So you see, this is one full house possibility when you have a triple and you have a pair as well. So now look, here is a way to do this. First of all, how many possible there even are? 5 choose, well, 52 choose 5. You have 52 cards, you're choosing 5 from them. But here's a question I have. How many possible are there that you would choose. How did you do that? How would you choose? First of all, let's think about it. How would you choose the 5? What is that? That's basically choosing just one from the face value. So that's 13. 13, okay? Right? That's some kind of, is it 555 or is it 222 or is it, okay, now, how do you do hearts, diamonds, and what is that one? Spades, for example, right? What happens here is you're choosing 3 suits from 4. So 4, choose 3, okay? That's 4, choose 3. Remember, that's the same thing as 4, choose 3, if you forgot what that's the same notation, okay? Now, okay, and then look, you also now, let's go to the jacks, okay, let's do this as kind of the first, the triple, and then times, well, what's a jack? Now, that's not a 5 anymore, so we have 12 face values left, right? Okay, this is one way to do this, and then how many do we have? Hearts, diamonds, we're choosing 2 from, we're choosing 4, choose 2, we're choosing 2 suits from the 4 possible, right? Because you have a heart diamond, you could have a diamond spade, you can have a heart club, whatever, right? Okay, so this is this, and then here's the other one more thing that you have to do. Remember how we talked, I said, I think that's it actually, one second, because do we have to divide by 2 or not? If 555 jack jack, jack 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 5 would be different, right? So order actually does matter here. We do not have to divide by 2. Really cool, right? And so more than likely, I would expect this to be the correct answer. The number of, what is it? Of, let's see, unless we can compute it, I'll get a calculator or not. It's not that bad. Look, 13 times, what's 4 factorial? 4 factorial over 3 factorial, 1 factorial, right? And so that's going to be, or yeah, that's how we usually, with that we usually write 1 factorial. What is it? 4 minus 3. So we'd first write 1 factorial and then 3 factorial, right? That's how we would do it for the choose, times a 12 times a 4 factorial over 2 factorial, 4 minus 2 factorial, and then 2 factorial. And that's going to equal to, look, that's going to equal to, what is that going to equal to? 13, let's just kind of, let me show you, obviously we can do this much quicker, but 4 times 3 times 2 times 1 times 12 times 4 times 3 times 2 times 1 on the top, numerator, and the denominator, there's a what? 3 factorial, 2 times 1. 1 factorial is just 1. Again, 2 times 1 and then 2 times 1, okay? Then you can put a 1 if you like. Okay, what goes away? 3 times 2 times 1 goes away, 2 times 1 goes away with 2 times 1. And what is 2 times 1? That's a 2 at the bottom. So we have, let's make this as a, this goes away with this 4 and make it a 2 there, okay? 13 times 12 is 156, okay? And then times a 4 left times the 2 and a 3, that's 24, right? 4 times a 6. Okay, what does that equal to? Let's see how we can do that quickly. I'm going to do maybe something fun, like 156 is a 2 times a 78 times, let's do 25 minus 1 for 24, okay? Actually, let's even do better. Let's do, it's 4 times 39, right? Cool, right? So 4 times 39 times this, and then what is that? Why am I doing that? Just for fun. 4 times 25 is 100, so we get 3900, 3900, minus the 4 times 39, 156, if you want to do that, okay? And basically that's going to equal to, just having some fun with numbers, 3,744. Now look, this is so easy to go wrong in this. Maybe we didn't divide by whatnot, you know, something and whatnot. So let's do this. Let's go and search this, okay? Let's search how many possible 5-card combination, what is it? Let's go online and let's go Google Chrome, number of possible, what is it? We call them full house combinations. How many possible, I don't know. Let's see. We could have not divided by something. I'm really kind of worried a little bit. Let's see. This is easy to go wrong sometimes with. It's loading. 3744. What do we have? 3744. Wow, right? So you see, after some practice, you get something going, right? So that's it. And so you saw how difficult something like this can be, but this is a combinatorics problem. And of course, if you wanted to take it a little further with probability, you would basically divide this number, like what's the chance you'll have a full house if you just get 5 cards? You would do that and divide it by the 52 choose 5. Right? The total possible, how many 5-card combinations there are, right? Just take 5 cards from 52. And you divide the 3,744 by that big number, much bigger, and you would get the chance that you would have a full house, which is actually very, very small. Okay, so let's end the video here, and later on we'll resume with the binomial theorem, which is really cool, but it will use some of these concepts, especially the permutations, and more importantly, combinations, the choosing. Okay, thank you, everyone.